So what we've done is found a way to combine gas and electric on each propeller, where we really leverage that high speed RPM change that the electric motors are capable of, but maintain that long duration and baseline power of the gas engine.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 295. What's a heavy lift drone, and how can it help transport cargo or support industrial applications? For that question, we head to Northern California to speak with Joshua Resnick, co-founder and CEO of Parallel Flight Technologies, an industrial-grade drone company with a mission to deliver unmanned systems to save lives, property, and the environment. Based in Selva Beach, California, the startup company has developed patent-pending drone technology that will allow drones to carry heavy payloads for over 2 hours, making it ideal for use in fighting wildfires, search and rescue, delivering healthcare payloads, and other mission-critical applications. As CEO of Parallel Flight Technologies, Joshua leverages his years of composite RC airplane and helicopter experience, his background in hybrid and electric powertrain, as well as his love for new technologies. Prior to founding Parallel Flight, he led system architecture and electrical engineering for the Tesla semi-truck program. He previously led state-funded research for the state of Alaska developing hybrid electric commercial fishing boats. In this edition of the Drone Radio Show, Joshua talks about Parallel Flight Technologies' heavy lift drone and how it's set up to revolutionize the public safety, healthcare, and industrial sectors. But before we hear from Joshua, I want to thank those of you who are supporting my funding campaign. Whether it's $1, $100, or much more, you can help defray the cost of production and keep the podcast going and growing. Go to droneradioshow.com/donate. And by the way, if you have an idea for a great show and want to share your experience, please contact me at randy@droneradioshow.com. So let's learn how heavy lift vehicles can support mission-critical applications with Joshua Resnick of Parallel Flight Technologies. Let's pick up the interview where I asked Joshua to introduce himself.
My name is Joshua Resnick. I'm the CEO and one of 3 co-founders of Parallel Flight Technologies, and we are building a new generation of heavy lift autonomous drones.
So Joshua, what is a heavy lift drone?
Our aircraft, our beta level aircraft that we're going to be putting on the market in 2021 has a payload of 100 pounds. So I guess, in my definition, it's any drone that has a maximum takeoff weight over, let's just say, the 55-pound rule, Part 107 rule, is heavy. But then, as far as we're concerned, 100 pounds of payload and up.
Where did the idea for a heavy lift drone come from?
The genesis of Parallel Flight really began in late 2017 after some of the catastrophic fires in California, specifically the fire in Santa Rosa. A number of friends of mine live up there and, were losing their homes. And that really got me thinking, what can be done differently to support the wildfire fighting industry? And so I ended up going to a drone show and connecting with the head of aviation for the Department of Interior. And we started talking, and it really became clear that the thing that was missing was unmanned logistical support, unmanned spot fire suppression, unmanned controlled burns. And all of these platforms would have to be, heavy lift, long duration platforms. So I started looking at, the technologies that were on the market, and it became clear that, there was a lot of unmanned helicopter platforms that were out there, but they were either super expensive and military grade or not readily available. And then, there was electric multi-rotors, but they really had incredibly short flight times, when they're lifting a substantial payload. We're talking 12, 15 minutes. And so I went back to the drawing board and said, how can we design a heavy lift, long duration platform from first principles?
Other than being heavier, how does it differ from what we typically see in a drone?
The fundamental difference is the powertrain. So when you think about multirotors, there's all electric multirotors, which pretty much everybody's familiar with, where you've got a battery or multiple batteries, and they're powering multiple propellers. Well, that, as I said, just from the physics of the energy density of lithium batteries, you're really only going to have about 12, 15 minutes of flight time when you're lifting a heavy payload relative to the weight of that aircraft. So that's just too limited for a number of missions that are out there. Then there's another variety or another breed of drone, which is the serial hybrid drones. And a serial hybrid drone is a gas engine powering a generator, which then keeps a battery topped off and powers the propellers. And the serial hybrid aircraft that have been built by several companies are excellent in terms of their duration capability. And I don't know exactly what the record out there is, but I think it's like pushing 6 hours of flight time. And some of these platforms, they're in the field and working great for a lot of different applications. But then when you want to do real heavy lifting relative to the weight of that aircraft, you want to avoid a lot of the power conversion steps between the gas engine and the propeller, but you still need that high speed response of the electric motor. So what we've done is found a way to combine gas and electric on each propeller, where we really leverage that high speed RPM change that the electric motors are capable of, but maintain that long duration and baseline power of the gas engine. And we developed what we call parallel hybrid system that has a high fuel efficiency and really minimizes conversion losses between the engine and the propeller.
How are the engines configured?
So for example, our aircraft that we're putting out has 4 gas engines and 4 electric motors. So 1 gas engine, 1 electric motor per rotor.
I'm trying to visualize how the gas and the electric engines work together. What can you tell us about the design?
There's a proprietary combination of gas and electric, and also that combination allows for redundancy. And this is something that we've demonstrated. We had a grant from NASA that we were working on to demonstrate this redundancy system. And we were able to show that, we could put the drone into any attitude and then induce a gas engine failure to simulate what a failure would look like. And the safety mechanism automatically detected the failure and switched over to all electric operation on that rotor seamlessly without any change or any real noticeable change in attitude of the aircraft.
How heavy is the drone?
It looks like our beta level drone is going to come in at around 120 pounds. I'd love to get that down to closer to 100 pounds for empty weight of the aircraft. But, for our first pass at this for beta, it's going to be around 120 pounds.
Now, what's your background? What were you doing before this? And how did you end up with a company that is designing something as revolutionary as this drone?
I really started my career up in Alaska developing hybrid powertrains for Alaskan fishing boats. I had a marine power company. We started off just doing straight marine power, just doing generator installs and boat engineering, and then ended up seeing a need in that market for higher efficiency diesel power. And we were able to get a grant from the state of Alaska and the federal government to develop high efficiency diesel generator systems. And then I was wrapping up that project and had an opportunity to come down to California and join a prototype team at Tesla. And the project that I was tasked with was the electrical engineering for the Tesla semi-truck. So this was about 5 years ago when that project was still, completely secret. And basically at that point, it was just a sketch on a napkin and there was just a few people working on it. And I was, like I said, heading up the electrical engineering and what we call system architecture, which is basically how do you combine all these Tesla subcomponents from cars to make a semi-truck. And so we built what they called alpha semi-trucks, the ones that Elon Musk revealed a couple years ago. And then after that project, pretty sure that was in 2017, after that project, I worked with the rest of the semi-truck team to start transitioning that over to more of a mainstream engineering project and not a prototype program. And it was at that time those fires happened. And, I've kind of always had this entrepreneurial bug. And I said, okay, we're going to go for it. We're going to start a company to try to help solve this problem of catastrophic wildfire.
So basically, powertrain systems and integration are things that you're well versed in and you have a good history.
Yeah, yes, exactly.
Does the drone have a name?
So the actual name of the aircraft has not yet been revealed. So we're going to have to wait a little bit for that. But what we're calling it right now is this is our beta level aircraft. So we had a prototype level aircraft that we flew in late 2019 and the beginning of this year. And we wrapped up those trials, I think Q2 of 2020. And I devoted all of our engineering resources to making this into a product that we could actually sell.
Is the heavy lift drone in production now?
So the first beta unit is being put together right now and is scheduled to have complete assembly done by the end of the year. And then we're going to begin flight testing in January. And then we're anticipating first deliveries to customers probably beginning of Q3.
In addition to the fire suppression and support, what other industries are you targeting for the system?
Industrial logistics, it's kind of a broad title, broad vertical, but industrial logistics and then healthcare logistics, which there's just becoming, a lot of really interesting opportunities, especially around the delivery of vaccines to rural areas. So in terms of industrial logistics, our first customer actually is doing power line construction. So right now they're doing power line construction with DJI, I think it's an M600 platform where they use it to pull a lead line, and then they have a special ground winch system that pays out the rest of the line, and it keeps going up in size until they're actually pulling power line. But they've just found that the small electric systems, they just don't have the pulling power, they don't have the duration required for their application. So they're super excited to be transitioning to a much larger, longer duration aircraft for that application.
Do you think you'll be able to get it down below 100 pounds?
I think going much smaller than 100-pound payload, the architecture is just not really amenable to that. And that's mainly because, the gas engines end up getting to be a little bit too small and you lose efficiency at those smaller displacements. And also the ancillary components like the spark modules and the controls, the circuit boards and controls end up just kind of becoming a dominant weight on the aircraft. But when you scale up, the spark module stays the same size and the circuit board, stays the same size, but the rest of the aircraft grows. So that kind of ancillary mass hit decreases and you just end up with an overall better mass efficiency. So I don't really foresee this architecture being super useful below that 100-pound payload level.
What's the anticipated flight duration of the drone?
So what we're seeing right now, because we already have what we call the hybrid power module, we already have that running on the test stand. And based on the fuel consumption and thrust that we're seeing, we're anticipating a full 2-hour hover with 100 pounds of payload.
When fully loaded, how fast can it go?
So we haven't tested this aircraft yet, but based on our previous prototype, I think we can, safely say that we're going to be able to hit around 50 miles an hour in forward flight with a full payload, but that needs to be tested out still.
I know you have an interesting mix of funding mechanisms. Can you tell us about them?
So this has been an interesting journey. We are funded by crowdfunding and also federal grants. We have grants, we had a grant from NASA that we completed, and we have active grants from the National Science Foundation and the USDA. And under the USDA is the Forest Service. So the grant from USDA is actually to develop a large-scale controlled burn platform for the Forest Service. So all that to say, we have federal grants And then the other capital for the company comes from crowdfunding. So, it was kind of an interesting journey. When we started the company, we raised about $250,000 when we first started from our family and friends networks just to do some initial testing and get off the ground. And then, talking with venture capital, it was pretty clear that they wanted to see more commercial traction before they're going to come in on a hardware play drone. Drones kind of went through this, what they call a fascination cycle. 2016, 2017 was like, basically, if you walked into a VC and said, hey, I'm building this new drone, they'd hand you a check for $1 million and you were on your way. But then it was just kind of a bubble, and the drone industry just didn't grow as fast as venture capital would have liked to have seen. So they kind of cooled off on drone investment and focused on, a smaller number of traction companies. So we kept developing good relationships with venture capital, but we realized we were going to need a different source of funding. And so we thought, look, we're building a product that really is going to support the public good. We want to get the public involved. And crowdfunding was a way to do that. We signed up on a platform called Start Engine, and we did what was called Regulation CF. And this was back in late 2019. And we raised $1.07 million, which is the limit. We raised that in about 2.5 months, which was pretty fast for a campaign like that. The public really loved it. They loved what we were doing. And subsequent to that, we've raised other money with different crowdfunding mechanisms. And now we have a large crowdfunding round that's available, which is called Regulation A. And this is something that's highly vetted by the SEC, and it's live on Start Engine. And so the public can get involved. And, we've already raised almost $650,000 in the basically 2 months. So it's going well, and it's funding our expansion and acceleration to get this product on the market.
What type of people are donating to the campaign?
Our investors are mostly just, everyday Americans. We've got some foreign investment as well, but primarily it's US investors. And this is kind of the beauty of crowdfunding. Prior to the Jobs Act, which was passed in 2016, only accredited investors could invest in startups. So an accredited investor is a high net worth individual. You have to have at least $1 million in assets outside of your primary residence to invest. And so that bar was pretty high, and it was just difficult for everyday people to get in on startups. And, startups are a sought after asset class because they have this very large potential upside. So then in 2016, there was this, what was called the Jobs Act, and that allowed anybody to invest in startups. And so a number of platforms were created to allow people to invest. So most of our investors are just everyday folks. For our first round, investments could be as small as $250. Now the minimum is $500. And we've had investors come in with $500. We have investors that come in with $100,000. So it's kind of a broad spectrum depending on how much people want to invest.
We talked about the engines being a big challenge. What are some of the other challenges that you had to overcome in designing the vehicle?
That's a good question. So there's a number of challenges especially when you're really developing like a novel powertrain. It's just not as straightforward as taking off-the-shelf components and putting together an aircraft. So one of the things that we kind of thought when we first started down this road was that, well, people can take their standard all-electric drones and they can, slap our power modules on and they can have a parallel hybrid. Well, that's not that simple. You really need a custom airframe to accommodate the powertrain. So it has to be a custom aircraft. So that was kind of an initial assumption that we've kind of proven wrong. And also the hybrid power module itself has gone through a number of iterations. I think we're up probably on version 5 of the power module at this point from when we first started. Every time we do an iteration, we learn a tremendous amount. It's just to say, it's highly non-trivial to incorporate a gas engine and an electric motor together seamlessly with all the electronics into this module. Also, the controls for the module are very sophisticated. So I have 3 full-time engineers that do, the programming for the microcontroller that actually operates that whole system, developing the circuit boards and stuff like that. So, that's another part of this that's become much more involved than what we previously thought when we started down this path.
Is the vehicle manufactured entirely by your company?
The airframe is totally custom. And so all the aluminum and carbon parts are machined specifically for the airframe. The electric motors, the gas engines are off the shelf with some modification. And then the flight controller is also an off-the-shelf flight controller. We're using the Verante flight controller from Invention. It's a very high-end flight controller, so significantly more costly than, say, the Pixhawk or something like that. We started with Pixhawk, but we went to a just more robust solution. But it is off the shelf. But then there's a number of other controls on board. We have our own custom PCBs and microcontrollers and code running the powertrain.
You mentioned that you always had an interest in entrepreneurial activity. Is this your first startup?
So it's my second company. In Alaska, I had a company that, like I said, it started off more as a job shop for marine powertrain. And then it became more of a venture going into the custom hybrid diesel space. But this is my second company, but this is requiring a lot more funding than my first company. And I think, if I would give some advice to entrepreneurs, it would be like, start a company that you don't need to pour a lot of funding into at first. Do something where you can develop a little bit more of that commercial traction up front without bringing in a lot of funding. But we're going down this path. We have a great commercial pipeline, but it is easier if you don't have to raise a ton of money.
If everything goes as planned, when do you hope to have the first official flight of the drone?
So I would love to have this flying in January. It's a super aggressive schedule, pushing the team really hard to achieve that. But, we'll just have to see if we can hit that. But that is certainly the goal.
Is there anything that we missed that we should talk about?
I think the other kind of exciting thing is, some of the partnerships that we've developed. So we have an exciting partnership with Drone Amplified, which is a US company that builds a controlled burn solution. Right now, their solution called Ignis is basically a payload that mounts on the M600, and it drops these spheres. They're like little ping pong balls, and they get injected with glycol right before they drop. And then they drop, and by the time they hit the ground, a chemical reaction causes them to burst into flame. And they're working with us to scale that up to basically go from carrying 400 balls to carrying almost 4,000 balls. And so we're going to build this large-scale controlled burn solution.
What else about the company would you like to share?
We've got a great team. I have 2 direct co-founders of the company. One of them comes from a military background. He was an engineer on a nuclear submarine, and then following that, he did some drone swarm work with the Navy. My other co-founder has a background in machine vision and industrial robotics. And then, we've hired a number of other engineers. We've got a team of about 10 people working on this full time. So we're growing, we're hiring, we're looking for technicians to do some of the assembly for our beta aircraft. Like I said, we're building one of those betas right now. We're going to pump another one out in January. So we're building aircraft, we're designing aircraft, we're doing a bunch of testing, we're going to be qualifying and flying and then getting these out to customers.
Why do you think this company and this drone will have a positive impact on the drone industry?
I believe that we're going to have a significant impact because we've developed a new technology that allows long duration, heavy lift autonomous systems to fly in difficult environments. And we've also developed a fantastic set of relationships with industry leaders, especially in the wildfire industry. So I think we're really poised to get into that market in a really unique way.
And for my final question, Joshua, what message would you like to leave regarding the future of the drone industry?
I know sometimes the drone industry moves more slowly than most of us would like, but I think that it is headed in the right direction. It's headed towards beyond visual line of sight. It's headed towards heavy lift. And, we're headed towards an exciting future. And, I would encourage drone entrepreneurs to jump in and get in there and do the work. And let's create an awesome future together.
That's it for episode 295 of the Drone Radio Show. I hope you enjoyed hearing from Joshua Resnick of Parallel Flight Technologies. I want to thank Joshua for taking the time to speak with me. If you want to learn more about Parallel Flight Technologies or want to connect with Joshua, check out the webpage at parallelflight.com. If you like the Drone Radio Show, please consider supporting the podcast with a small donation. The content is always free, but for as little as $1, you can help defray the cost of production. To donate, go to droneradioshow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Gores.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.